Hello and good day everyone. I am Noura Harazli. My team members and I will be presenting on the next research design, which is correlational research designs. I will be the first presenter and will be presenting on definition and types of design. Shasha will be talking about the first three key characteristics, and Susan will continue on the last key characteristics and potential issues and steps, while Hanis will be talking about the evaluation and sample studies. So what is correlational research design? So according to Creswell 2021, correlation statistical tests used by investigators to describe and measure the degree of association between two or more variables or set of scores. In this design, researchers do not attempt to control or manipulate the variables in the experiment. A correlation reflects the strength and or direction of the relationship between two or more variables. So this direction can be either positive or negative. So how do we measure the degree of association of two or more variables? So we measure it using the correlation coefficient, which is also known as Pearson's R. So it is commonly used to assess a linear relationship between two variables. Below is the image of the formula of the Pearson's R. This is the comparison between correlational study versus experimental study. As we can see here, both studies have very distinctive features which can be explained further. So the purpose of correlational study is used to test strength of association between variables, while experimental is used to test cause and effect relationships between variables. And variables in correlational study are only observed with no manipulation or intervention by researchers, while experimental has an independent variable which is manipulated and a dependent variable is observed. In correlational study, limited control is used so that other variables may play a role in the relationship, while extraneous variables are controlled in the experimental study so that they can't impact your variables of interest. Correlational have a high external validity, where you can confidently generalize your conclusions to other populations or settings, while experimental study has a high internal validity, where you can confidently draw conclusions about causation. So those features really reflect the difference on both studies. They are very different from. So when do you use correlational study? You use correlational research when you seek to relate two or more variables to see if they are associated with each other. For example, the relationship between teachers who endorse appropriate practices and their use of the whole language approach to reading instruction. This design also allows you to predict an outcome, where the prediction that ability, quality of schooling, student motivation, and academic coursework influence student performance and achievement. It is also used for assessment and testing research, such as testing the correlation of scores on two different measures to gather evidence of validity. You can also use this design when you have the skills to apply this statistical knowledge based on calculating the correlation statistical tests. You might be wondering, how did correlational research develop? So historically, correlational research developed based on the origin and development of the correlation statistical test, and also the procedures for using and interpreting the test. So in the late 19th century, statisticians first developed the procedures for calculating the correlation statistics. And during the last half of the century, Carl Pearson presented his correlation formula. Pearsons are before the Royal Society in England. Interestingly, he used illustrations from Darwin's theory of evolution and Sir Francis Galton's ideas on heredity to advance his ideas about correlation. Since then, Pearson was the only several British biometricians who discovered and refined the ideas about correlation. But in 1897, his student Yu developed solutions for correlating 2, 3, and 4 variables. Later in 1904, Spearman published ideas about a correlation matrix to display the coefficients, and he advanced his own formula, Spearman's rule, for the data that did not fit a normal bell-shaped distribution. Years later, in the 20th century, in 1935, Fisher pioneered significance testing and analysis of variance, important statistical ideas for studying the difference between observed and predicted scores in correlational analysis. So later, until 1963, Campbell and Stanley provided new impetus to correlational research with their classical treatise on experimental and quasi-experimental designs. During the 1970s and 80s, the advancement of computers emerged. It improved the knowledge about measurement scales, the need to study complex associations among many variables. Instead of physical control, through techniques such as randomization and matching, correlational researchers sought control through statistical procedures. With computers, they could statistically remove a large number of variables and could explore the combinations of variables. So with the help of technology today, researchers test elaborate models containing many variables. So we're moving on to the next subtopic, which are primary types of correlational designs. So we have two, which are explanatory design and prediction design. The explanatory design is also known by various authors as relational research, accounting for variance studies, and also explanatory research. So because one basic objective of this form of correlational research is to explain the association between or among variables, we use the term explanatory research. So this explanatory research design is a correlational design in which the researcher is interested in the extent to which two variables or more co-vary. That is, where changes in one variable are reflected in changes in the other variable. This design also consists of a simple association between two variables, for example, sense of humor and performance in drama, or more than two variables, for example, pressure from friends or feelings of isolation that contribute to binge drinking. So when we look at a research papers, we wanted to identify what types of design was used. So in order to do so, we can actually look at these characteristics of an explanatory design. First is the investigators correlate two or more variables. So these researchers report the correlation statistical test and mention the use of multiple variables, so readers can find these variables mentioned in the purpose statement the research questions, or also the tables reporting the procedures. Secondly, the researchers collect data at one point in time. So it can be found in the part of administration of instruments. It will say that the data was collected in one sitting. So the investigators in this design, the investigators are not interested in either past or future performance of participants. Next is the investigators analyzes all participants as a single group. Compared to the experimental design, it involves multiple groups and treatment conditions. However, in this study, the researcher collects scores from only one group and does not divide the group into categories. So all levels of information from the group are used rather than dividing the scores. For example, on self-esteem into high and low categories. In correlational research, the researcher used all scores on a continuum, such as from 10 to 90. The fourth characteristic that can be found in an explanatory design is the researcher obtains at least 2 scores for each individual in the group, 1 for each variable. So in the method discussion, it can be found that the researcher will mention how many scores were collected from each participant. So for example, each individual in the study of optimism and appropriate health behaviors, the researcher will collect 2 scores, an optimism score and also a health behavior score. Next, the researcher reports the use of the correlation statistical test or the extension of it in the data analysis. So this is a basic feature of this type of research. The researcher includes reports about the strength and direction of the correlational test to provide additional information. Lastly, the researcher makes interpretations and draws conclusions from the statistical test result. The conclusions in this type of design, correlational design, its conclusions do not establish a probable cause and effect relationship because the researcher can use only statistical control rather than the more rigorous control of physically altering the conditions. So in this research, the investigator takes the participant as they are without experimental intervention. So authors of this study often use the phrase such as degree of association between 2 variables, which is a connotation that conveys a general co-occurrence between variables rather than a probable causality. So this also explains why sometimes writers of this design refrain from using terms such as independent variable and dependent variable, but instead they refer it to the correlation of 2 variables, meaning to say it is consistent with something less than the independent variable influencing the dependent variable. They also employ the words relationship or association about correlations among variables. The next type of correlational design is the prediction design. So in a prediction design, researchers anticipate outcomes by using certain variables or predictors. So prediction studies are useful because they help anticipate or forecast future behavior. The purpose of this design is to identify variables that will predict an outcome or criterion. So the researcher identifies one or more predictor variable and a criterion. Criterion is also called as outcome variable. Predictor variable is used to make a forecast about an outcome in correlational research. Criterion variable is the outcome being predicted in the correlational research. So for example, the principals wanted to know teachers who have a chance to be successful in teaching in schools. So in the method of selecting the good teachers who will have a very high chance to be successful in the schools, so um, they can identify predictor variable and also criterion variable. So the predictor variable here would be, for example, mentoring during teacher training or years of experience teaching. So in prediction research design, investigators often use more than one predictor variable. So it can be mentoring, it can be years of experience in teaching. So the outcome that the researchers wanted to predict or wanted to forecast is criterion variable. So in this case, criterion variable is a teacher's success. So to identify the prediction study, we should have a look on the following characteristics. In a research paper, the authors typically include the word prediction in the title, or it could be also be in the purpose statement or research questions. And in this type of design, the researchers typically measure the predictor variables at one point in time and the criterion variable at later point in time. So the researchers have to build some sort of a time dimension into the design, so they have to come up with a predictor variable first. For example, previously mentioned, the predictor of teacher success, such as mentoring, is measured during students' teacher training program, whereas success, which is a criterion variable, is measured later after the students have performed as teachers. So the final characteristic is the authors forecast future performance. So the researchers usually wrote their intention in the paper statement or in the research questions. So in the justification of the research problem also, they mention their intent to predict some outcome. So I think that's all for my part. I will pass the floor to Shasha.
Okay, hi everyone. So my name is Nur Shahira binti Sahe, and today I'm going to present to you about the key characteristics of correlational design. So there are 4 characteristics here, which are association between scores, display of scores, multiple variable analysis, and using advanced correlational statistical procedures. So I'm going to explain to you about the first one, association between scores. So when we examine a graph, it is important to first identify if the points are scattered or if a pattern exists in which the point move in the same or the opposite direction. So in the positive correlation, the point move in the same direction. That is when x increase, so does y, or alternatively, if x decrease, so does y. While in a negative correlation, the points move in the opposite direction. That is when x increase, y will decrease, and when x decrease, y will increase. So if the scores on one variable do not related in any pattern on the other variable, then there is no linear association exists. So here are the form of the association. We have 2 types of form here. The first one is linear and the next one is non-linear. So in linear form, we have positive and negative. So the correlation researchers identify the form of the plotted scores as a linear or non-linear. So linear are separated into positive and negative. The positive linear relationship means that as scores on one variable increase. So the scores on another variable increase at a steady rate. While in negative linear result, low scores on one variables relate to high scores on the other variable. Next, we have the nonlinear relationship, or we can also call as curvilinear distribution. It shows a U-shaped relationship in the scores where you can see in D and also E. So in distribution D shows an increase and decline in the y-axis variable with increasing values of the x-axis, while in the E here indicates a decrease and increase in y-axis variable with increasing value of the x-axis variables. Okay, so this is the degree and strength of the association. So degree of association means that the association between two variables or set of scores. So set of scores in the correlation of coefficient of negative 1.00 and positive 1.00 with a 0.00 indicating nonlinear associations at all. So the statistic provides measure of the magnitude of the relationship between two variables. However, some researchers prefer to square the correlation, and the results calculated can measure the strength of the relationship using the coefficient of determination, which access the proportion of variability in one variable that can be determined by second variable. So these are the general guidelines for the interpreting the strength of the association. So we have size of coefficient and the interpretation. So for the 0.20 to 0.35, when the correlation range at 0.20 to 0.35, there is only a slight relationship. So this relationship may be slightly statistically significant for 100 or more participants. So this size of coefficient may be valuable to explore the interconnection of variables, but of little value in prediction studies. Next is 0.35 to 0.65. So when the correlations are above 0.35, they are useful for limited prediction. They are the typical values used to identify variable membership in the statistical procedure of factor analysis. Means the intercorrelation of variable with a scale, and many correlation coefficients for the relationships fall in this area. Next, we have 0.66 to 0.85. So when the correlations fall into this range, there is a good prediction. A good prediction can result from one variable to the other. So coefficients in this range would be considered very good. And the last but not least is 0.86 and above. So the correlations in this range are typically achieved for studies of construct validity or test-retest reliability. In fact, the researchers want their reliability and validity test correlation to be this high. So when two or more variables are related, so the correlations this high are seldom achieved. And if they result, then two variables actually measure the same underlying traits and should probably be combined in data analysis. Next, I'm going to explain about the display of scores. So display of scores, we have two types here, which are scatter plots and also correlation metrics. So what is a scatter plot? Scatter plots shows a relationship between two qualitative variables measured for the same individuals. So the values of one variable appear on the horizontal axis and the values of the other variable appear on the vertical axis. So each individual in the data appears as a point on the graph. So as you can see here, so the hours of the internet use variable is plotted on the x-axis, is here, and the depression variable is plotted on the y-axis, which are the vertical axis. So it is here. Now, each student has two scores. One is for their hours per week of the internet use, and another one is for the depression. So a mark or point on the graph indicates the score of each individual on depression and hours of internet use each week. So there will be 10 points on the graph. So one on each point will be for each participants in the studies. So here are the three important aspect about the score. So number one is the directions of scores. So the direction of scores shows that when X increases, Y increases as well. So indicating a positive association. Number two is point on the scatter plot. So the points on the scatter plots tend to form a straight line. So as you can see here, it is a straight line. Next, number three is the reasonable of the point. So the points would be reasonably close to a straight line if we were to draw a line through all of them. So these three ideas related to directions, form of the association, and the degree of relationship that we actually can learn from the scatter plots. So we can use all this information when we discussing about the association between scores in the correlation studies, correlation or correlation research. Okay, so the next part is correlation metrics. So a correlation metrics present a visual display of the correlation coefficients for all variables in the study. The metric depicts the correlation between all the possible pairs of values in a table. It is a powerful tool to summarize a large database and to identify and visualize patterns in the given data. So as you can see here, coefficient ranging between negative 0.33 and positive 0.65 are reported in the cell here. So negative 33 and 0.65. The table was filled up only the lower half of the cell. So the asterisk indicate whether the coefficient statistics are statistically significant correlated at p 0.05 or p.01 levels. Okay, so next I'm gonna explain to you about the multiple variable analysis. So in multiple variable analysis, we have three parts here, which are partial correlations, multiple regression, and meta-analysis. So in partial correlation measures the strength of a relationship between two variables while controlling for the effect of one or more other variables. So as you can see here, here is the picture of two variables, okay, followed by the inclusion of third can help explain partial correlation. So in the bivariant, shows a bivariant with two two variables correlation on the left hand side, and the partial, it's this one, three variable correlation analysis on the right hand side. So we assume that a researcher conduct a study correlating time on task with achievement for middle school children. After gathering the scores, our investigator calculates a correlation coefficient with the result of R equals to 0.50, which you can see in the figure 11.3. It indicates this association as well as the R square, or the proportion of common share variance between the two variables. However, the situation is more complicated, where the student motivation, a third variable, may also influence both the student's time of task and their achievement in class. So the researchers identified this third variable based on a literature review and a study of past series that have shown factors likely to influence students' achievement. Okay, so in the design, motivation needs to be removed so that the relationship between the time on task and the achievement can be more clearly determined. So a partial correlation statistical analysis is used that removes the share variance in both time on task and achievement by motivation. So the mathematical calculations for the coefficients are available in the statistical books. So it is actually based on the correlation coefficient among all three variables and their variances. Next, we have the multiple regression. Multiple regression is an extension of simple linear regression. It is used when we want to predict the value of a variable based on the value of two or more variables. So as you can see here, this is actually a simple regression line. This is a simple, it is a best fit for all points of score on the graph. So the calculation of the lines holds value for predicting scores on the outcome. For example, here is the depression score. With knowledge about the predictor, hour of internet use per week. So based on the mathematical formula, a researcher can calculate an equation that expresses this line. So y predicted equals to b bracket x plus a, where y is equals to predicted score of depression, x is the actual score of number of hours number on hours of internet use, b is the slope of regression line, this is the slope of regression lines over here, and a the intercept or a constant, the value of predicted y depression score when x is equals to 0. So when you substitute the number here, if a equals to c equals to 6, b equals to 2.5, and x equals to 14, whereby y predicted is equals to 2.5 bracket 14 plus 6, so the answer will be 41. So the y predicted is 41. Next is the meta-analysis. So meta-analysis is a qualitative set of technique for analyzing results from two or more studies on the same or similar issues. It's coming 2011. So the goal of meta-analysis is to understand the result of a single study in the content of all studies on the subject. All right, so here are 6 steps in conducting a meta-analysis. So the first step is problem formulation. So there must be a person who wants to do a researcher who wants to do her research must have enough study on a subject before the quantitative review can be proceed. Next is searching database and gathering studies. So the researchers gathers all the relevant literature in a systematic manner by searching databases, examining review articles, and obtaining research that has not been published. The third one is criteria for review. So the researchers codes the study based on the criteria about the study as well as basic characteristics of our studies. For example, the sample size and the outcome of the variables. Next, number 4 is the effect size. So a statistical analysis of the study results is completed. So the effect size are noted for each study with the dispersion of effect size for the studies taken into account, and the effect size are averaged. If available, a confidence interval is noted for the effect size, weights are assigned for the sample sizes of each studies, and the p-value are noted if available. Next is E. Next is number 5 is summary effect. So a summary effect is calculated. For moderating variables, the researchers may compare the effect size for different subgroups or studies versus the others to determine what accounts for the variables in the effect size. So moderated variables consist of varying characteristics of the participant across the primary studies, such as gender, age, educational level, or across varying kinds of design. And the last but not least is the interpretation. So the researchers interprets the meaning of the summary effects across all the studies to determine the magnitude of effects. So some of the key decisions researchers must make in meta-analysis are whether the review of studies should be limited to published articles, whether flawed study should be included, how missing data in the study should be addressed, how to incorporate into a summary report studies with multiple effect size, and whether the errors of studies are due to chance, fixed effects, or random effects in the study's design. So that is all from my part. Now I will pass the presentation to Susan. Thank you.
Good evening, everyone. My name is Susan, and I will be presenting on the advanced correlation statistical procedures, potential ethical issues, as well as the steps in conducting a correlational research. Right, so we'll start with the advanced correlational statistical procedures. So in this subtopic we have 6 advanced procedures. So that includes factor analysis, discriminant functional analysis, intra-class correlation, path analysis, structural equation modeling, and hierarchical linear modeling. So we'll start with the first one, which is factor analysis. So factor analysis is a way to take a mass of data and shrinking it to a smaller data set that is more manageable and more understandable. It is a way to find hidden patterns and show how those patterns overlap and show what characteristics are seen in multiple patterns. So in order to reduce the larger number of variables, we break them into smaller sets. This approach is to look for clusters of variables in which all the variables in the cluster are highly correlated and have low correlations with others. So that is the whole definition of factor analysis, which is to take the bigger variable and breaking them into smaller sets of data. Right? So we'll move to the second one, which is discriminant functional analysis. Now, it is an advanced statistical procedure for determining what independent variable best explains the difference among the categories among the dependent variables. So in this, we have to consider what factors then predict the differences between the two types of scores. So we use this analysis when the dependent variable is a categorical variable, which is gender, sex, etc. And the independent variable is a continuous variable. In a discriminant analysis, we can find out which factor are the most important based on the functional discriminant score. So when doing this analysis, our variables would include a categorical variable as well as the independent variable would be a continuous variable. So that is the discriminant function analysis. So we would move to the next one. The next one is intra-class correlation. So Intra-class correlation is a statistical test that we use to measure correlation when data are in groups. So this is useful in other situations involving groups. For example, analyzing data within family where we are looking at common traits. Now this analysis can be useful when the unit of measurement in the quantitative research are in groups. So this would mean that instead of looking for the data in paired observation, we look at the data in group observation. So intra-class correlation is mostly focused on group observations. The next one is path analysis. Now, path analysis is a statistical procedure for looking at the likely causal relationship among 3 or more variables that influence the outcome. We determine what focus have a direct influence on the outcome and which one are mediated by other variables. Now, this also involves looking at what influences what. So we look at the cause and effect of the variables toward the subject. Besides that, this is also described as the dependencies between variables. So that is path analysis. So we move to the next one, which is structural equation model. Now, structural equation model is a linear cross-sectional statistical technique that consists of a family of related procedures. So the analysis relationship among multiple variables at the same without increasing error rate as would help if we conduct as would happen if we conduct regression analysis multiple times on the same set of data. Now, structural equation modeling is also called covariance structure analysis, covariance structure modeling, or analysis of covariance structure. So the basic idea of structural equation modeling is to provide extensive information about which variable affect other variable and the direction of the effect. So we can see that structural equation modeling focuses on the causal effect of the variables toward each other. So looking at what affects what. Right, so we'll move to the last one, which is hierarchical linear modeling. So hierarchical linear modeling provide a conceptual and statistical approach for investigating and drawing conclusions regarding the influence of phenomena at different levels of analysis. So such models are applicable when there are different units of analysis at different levels. Now, hierarchical linear modeling is also called multi-level linear model, mixed effects, and as advanced approach to linear regression. So in the second point, such models are applicable when there are different units of analysis at different levels. That is when units are clustered within larger units. So now that we've covered the 6 different advanced procedures, we will move to the next subtopic. We will now move to the potential ethical issues in conducting correlational research. So the potential issues, there are 3 main potential issues. The first one being, it is considered unethical to not have measured appropriate controls. These controls include age, gender, race, etc. Now this is a problem, especially if controls are omitted that other researchers have especially pointed out. This could cause inaccuracy of data as the researcher did not take into consideration that those factors may affect the result. To help the problem, the researcher could use a conceptual model or theory to help them select appropriate variables for measurement. This way, all possible predictors are considered and would help the researcher as the study itself needs a bigger sample size for accurate data collection. Now, the second potential ethical issues can be found in data analysis. Now, researchers are cautioned about editing or making up the data. They have breached ethics when they say that they have found cause and effect, when in reality, their results only show patterns of relationship. The failure to analyze and report effect sizes in addition to null hypotheses that can be considered as unethical. So another ethical issues that can be found in data analysis is the treatment to outliers, which would include the removal of outliers themselves. So researchers must be clear and transparent about reporting their rationale and procedures with the outliers as well. Now, the last potential ethical issues can be found in data reporting and presenting. There are 4 words that would conclude this thing, and it is plagiarism is a no. Now, plagiarism includes words, failure to report contradictory finding, publishing the same evidence many times, and omitting negative findings. Now, good ethics includes the willingness to share data with others and not let reports sit unused. The failure to abstract and analyze the finding of multiple studies and how this leads to erroneous results is considered unethical. It is also unethical for researchers to exclude studies because of small sample size and insignificant results. So now that we've covered the potential ethical issues, let's look at the steps in conducting a correlational research. So there are 6 steps that we can use in conducting a correlational research. So we will be going in detail of all the steps as well as looking at it much clearer. Okay, so we move to step number 1. So step number 1 is to determine if correlational study best addresses the research problem. So correlational research exists to study a problem requiring the identification of the direction and degree of association between 2 set scores. Now this would mean is to see the association that we can see between the 2 set scores. Correlational research is useful for identifying the type of association, explaining complex relationships and multiple factors that explain the outcome and predicting an outcome. So this would mean that it would come in useful especially when we are looking at associations between 2 different variables that can include a much more complex or something more like just 2 variables. So just to be clear, correlational research does not prove relationship, but rather show association between variables. So an example of research question that we can see in correlational research is creativity related to IQ test scores? And an example for hypothesis is creativity is not related to IQ scores for elementary children. Now, once we have determined that our research requires a correlational study, we will move to the second step, which is to identify individuals to study, or in other words, to look for your samples. Now, just to remind, you need an adequate size that must be chosen at random. Okay? The researcher should randomly select participants because the study itself needs a large sample size as the sample size contributes to less error and claims better representativeness. So for example, a correlational study should include at least 30 people or 30 participants. Now before being able to carry out your experiment, you should seek permission to collect the data. Now once you've selected your sample, you move to step 3, which is to identify 2 or more measures for each individual in the study. Because the basic idea for correlational research is to compare participants in a single group on 2 or more characteristics, variables must be identified. Now where do we get the variables? The variables can be obtained in literature. Now besides finding for your variables, you should also seek for your instrument. Now the instrument is used to measure and obtain the and help administer and get your results. So the instrument that you use should and must be valid and reliable. So in order for us to get a reliable instrument, we should seek previous research. We should seek it from literature. And if we need an instrument, we should obtain permission from publishers or authors to use it. Right? So once we've obtained our variables as well as obtained our instruments, we move to step 4. Step 4 is to collect data and monitor potential threat. So this is where the researcher would administer the instrument and collect at least 2 sets of data for each individual. Now why 2 sets of data? Now we need 2 sets of data in order for us to obtain accurate results. Okay, so the data needs to have association between 2 variables. Like we said, correlational research is to look at the association between 2 variables, right? So once you've collected your data, you move to step 5, which is to analyze the data and represent the results. So here, investigators must look for patterns of responses and use statistical measure to show the strength of the relationship. Now, statistical significant relationship, if found, does not imply causal. Yes, correlational research does not imply causal. So even if you get the relationship, it does not show causal. Causal meaning cause and effect, alright? But rather, it is to show association between the both. Alright? So the researcher needs to determine appropriate statistical use. So they should consider whether only one predictor variable is being studied, whether a mediating variable explains both the predictors and the criterion variables and needs to be controlled. And the third one, whether more than one predictor variables needs to be studied to explain the variability in the criterion variables. Okay, right. So these are things that you need to look out for or need to consider, especially when you are administrating a correlation research. Now, if you're using a statistical test, abbreviate the study by considering setting of alpha level, using the critical values of the R table available in many statistics books, using degrees of freedom of n equals to 2 with this table, calculating the observed R coefficient and comparing it with the practical use, rejecting or failing to reject the null hypothesis at a specific significance level. Now these things to consider can be found in the textbooks. Alright, so now once we have analyzed the data, we come to step 6, which is to interpret the results. Now, interpreting the meaning of the results requires discussion of the magnitude and direction of the results itself. So, considering the impact of mediating variables in partial correlational studies. Besides that, the researcher should also be interpreting the regression of weights of variables in a regression analysis and developing a predictive equation for case in a prediction study. So the overall concern is if the data supports the theory, hypothesis, or research question. So you should also report the results, whether it confirms or does not the findings of other studies. So a reflection is made on if some of the threats may have contributed to erroneous coefficients and steps that might be taken by future researchers to address the concerns. So these are the things that should be included as you interpret the study itself. All right. Without further ado, this is the end of my part, so I will pass on to the next speaker. Thank you for listening.
Hi, my name is Hanis Rahana, and I will be presenting about the criteria for evaluating correlational studies. So first of all, in order for you to evaluate correlational studies, there is an indicator for you to have known about whether the correlational studies that you are evaluating is is a high quality one or a lower quality one. So the key elements are for you to have an adequate sample size for hypothesis testing. So a high quality correlational studies would have 30 participants or more. Next one, the researcher must display correlational results in a table or a graph, and the researcher must present a complete correlation matrix with all of the variables being correlated. Next one is the researcher selects an appropriate statistical test. So the researcher must have selected the proper correlational statistics based on the types of scales being used in order for him to measure the variables in a study. Next is there must be an interpretation about the direction and magnitude of the association among the variables. So the researcher must report on the strength of the relationship based on some standard and for him to assess whether it indicates a slight relationship, a limited prediction, or a good prediction. Next is an assessment must be made about the magnitude based on the association, based on the coefficient of determination, p-values, effect size, or size of the coefficient. The indicators for a higher quality one, the researcher must at least provide the p-values, the effect size, and the confidence intervals in reporting the correlational analysis. Next, the predictor and criterion variables must be identified by the researcher. So the researcher must have identified the predictor and criterion variables and provide a definition about how they will be measured in the study. Last but not least, the expected or predicted direction is already been presented in a visual model based on observed data. So the researcher must present a visual model of the hypothesis relationship among the variables and for him to indicate whether this model the correlations among the variables. This is an example of a correlational study. The following example has been extracted from the 4th edition of the textbook that we have, the educational research. So we have extracted the example from the 4th edition. So from this correlational study, you can see that you can actually recognize a correlational study based on the title alone. So there would be a correlational design characteristic and marginal annotations. So as you can see here, the influence of parental attachment on the college adjustment of white, Black, and Latina or Hispanic women across cultural investigation. So the variables here are white, Black, and Latina or Hispanic women. So the researcher is focusing on the influence of parental attachment on the college adjustment. So you would have seen this on the title, so you would have recognized whether it is a correlational study or not. Next is you can see the multiple variable analysis are being applied in the method. So you would have procedures, and then you would have process, and then you would have measures. All of these measures are being taken in order for the researchers to control statistically in terms of the variables. So the researcher had provided a demographics questionnaire, a parental attachment questionnaire, and college adjustment measure. So based on these variables, the researcher are trying to look for the influence of parental attachment on college adjustment, but the variables would be on the Black, white, and Hispanic or Latina woman. And the results, the analysis on the multiple variable would have appeared in the results. So as you can see, the data analysis here was conducted in 4 distinct steps. So first you would have the descriptive statistics and frequencies. So you would have calculated that from the demographic information. So secondly, the intercorrelation matrix, including all key variables of interest, was computed. Remember that we have spoken about the criteria of evaluating a correlational study. So you would have to have an intercorrelational matrix, including all of the key variables of interest. And then next, thirdly, is for you to assess the influence of the demographic factors, you would have to have a proper statistical set. So you would have here a 2 times 4 maneuver, race times parental college education. So the researcher was using the 4 subscales of the SACQ as dependent variables. And lastly, a series of stepwise multiple regression analysis were calculated. So as you can see here, the results are very thorough, and the analysis are being computed based on multiple variables at once. So the discussion, the correlational analysis, as you can see here, the researcher has annotated the associations between scores. So you would have total group correlations and also including the racial or ethnic subgroup correlations. That's not all. There are more underneath it, but I will actually link it for you to take a look later in the group. So inside, you can see the Pearson correlation and matrices were conducted for the total sample group and for each of the 3 racial or ethnic subgroups. So you would have the variables age, parental attachment subscales, and the 4 college adjustment subscales, which is the SACQ. And then in the discussion, you would have the displays of scores in a matrix, and here you would have the intercorrelational matrix being drawn here in order for you to see the relationship in between the variables. In conclusion, correlational study is about observing the connection or relationships among the variables. It is not as rigorous as experimental because it's not for you to prove the relationship, it's for you to discuss on the relationship or the association that has been made in between or among the variables. It can be done on intrinsic issues such as parental attachments, student approaches to learning a second language per se. So correlational studies can be used to predict the direction and the magnitude which can be observed from the data gathered. So the association among these variables can form a relationship in which will help future researchers to discuss and study more on strengthening the results or for them to monitor potential threats to the validity of the score. It's for the researchers to keep track on whether all of these scores are changing or not, whether they are keep evolving or not. So as you can see, between the connection and relationships, they are trying to find whether perhaps the validity of the score has changed or has evolved around the years. So you would have to find another connecting variable to it. So you would have to perform another correlational study in order for you to find out or for you to predict the outcome of the study. So it is best to keep in mind that by understanding the intent of the coefficient being substituted in your study, it would help you to determine the results in a correlation study because all correlational study have to use coefficient as their base of analysis. So in order for you to know the intention of you using the coefficient, it would help you to determine the results in your correlational study. So as you can see, if you would want to produce a grade like a correlational study, you would want to identify whether you would want to make a connection between the relationship among the variables or between the variables, or for you to use a correlational study in order for you to predict the outcome. So it can be used either way, but it's not going to be as rigorous as experimental, as I said, because it's not for you to prove the relationship whether it is correct or not. It's not for you to prove whether it is accurate or not. It's for you to find a common ground and within these variables, and for you to observe the connection and relationships in order for future researchers or you for you to predict the outcome. In order for you to have that kind of variables, that kind of framework for you to predict the outcome, or to have a more understanding on how future will work sooner or later. So thank you.